Okay, so continuing on with our work on linear programming, we're now going to put all of the things we've learnt together. That's variables, remember things that don't change, that change. Parameters, information from the question that don't change. And constraints, which is what we learnt last lesson, which is ways that our information limits our possible answers. We're going to put all of those things together to come up with a decision for our problems. So in lots of cases, there is more than one constraint. In fact, that's very normal. So far we only plotted one constraint, but in reality, there's often more than one. And what we do is we graph them together on the same set of axes. And what we're looking for is the area on our graphing that overlaps. That overlapping section is called the feasible region. And that's where our best decision-making area is going to be, in that feasible region. So let's look at a problem and work through it. So in this problem, Mohammed can afford to spend up to $2,000 on new equipment for a sound studio. He must buy at least 12 microphones. Microphones are $80 each and headphones are $120 each. So let's work through the problem that we've got here. So, A, identify the variables and parameters. Now, as I've said before, even if it doesn't ask you to do that, you should be doing that every single time for a linear programming question. So variables, I'm going to use M and H. M for microphones, and that's the number of microphones. And remember, you can use X and Y instead if you would like. So you could use X here instead. And I'm going to use H for number of headphones. And again, you could use Y here. So if you'd prefer to do that every time, feel free to do that if that makes it easier to plot. So there are variables. Now we need to look at our parameters. So parameters are the things that don't change. In this case, we're told that there's a minimum number of microphones we need to buy. So that is going to be something that is important here. So minimum number of microphones. In that case, it's 12. Now, in a similar way, we're not told anything about a minimum number of headphones, but what that allows us to do then is assume that we don't have to buy any headphones. So the minimum number might be 0 here. And that can actually help us determine our region as well. So these should always usually be minimum or maximum parameters as well. Now, we're also told about the cost of each one of those things. So the cost of the microphones is $80 and the cost of the headphones is $120, so that's important. And we're also told our maximum cost, or our total budget, is $2,000. We don't have any more dollars than that. So all of those are things that we can't change and are important to this question. So that's A. B, write the constraints. So this is continuing on from what we did yesterday. So what we did to write constraints was we used the variables and parameters together. So you need to practice writing constraints based on those questions I set for you yesterday. But the obvious constraint we're going to have here is the total cost. We've only got so much money and we've got to buy a certain number of microphones and headphones with that. So let's think about it, how we're going. So if we have a certain number of microphones, each one of them costs $80. 80 times M. Plus we might buy a certain number of headphones and each one of them costs $120. Now, $2,000 is the most we have to spend, and that is the most. So instead of being equal to $2,000, it's going to be the cost of our microphones and headphones have to be less than or equal to $2,000. So I'm just going to simplify that a little bit further. We don't need those multiply signs. If you can go straight to writing this constraint like this, do that. But if you need a few steps, that's also fine. So that is going to become our constraint number 1. And that takes into account the cost of the items and the maximum cost. So we've taken those, that, and that into account so far. Now, the other ones that we haven't done anything with is those minimums. So the minimum number of microphones and the minimum number of headphones. So the number of microphones, remember that's M, has to be at least 12. So that means the number of microphones that we buy has to be greater than or equal to 12. The number of headphones that we buy has to be greater than or equal to 0. So these are going to become our two other constraints. Now I'll just remind you what we do when we have, just flick back to an old lesson that we did, when we have only one variable in there. So remember, let me find that. When we only have one variable in there, what happens is we have a line that is parallel with one of the axes, either a horizontal or a vertical line. So don't be afraid to get equations that only have one variable. That's perfectly fine. It's going to mean, though, that you have a horizontal or vertical line, and that's fine. So these constraints are talking about the minimum quantities required. Now, we have now taken care of all 5 of those parameters and we've used our variables. So there's nothing left, so there's no more parameters, no more constraints to draw than this. So they are all the constraints that we're working with in this situation. Okay. C, draw a graph and shade the region defined by the constraints. So this is exactly the same as what you've already done. You're going to take those 3 constraint equations, or inequations in this case, and you're going to draw them all on the same axes. So let's start that process. So for the first one, 80m plus 120h less than or equal to 2000, we need to figure out a way to plot it. So remember we did the table method, but we also use the intercept method. So plot all on the same axes. That's important. Don't plot them separately, because if you do plot them separately, you're not going to be able to solve this problem. So I'm going to find the intercepts. I'm going to use the intercept method. It's actually probably more useful, so it's really important that you understand and can do that. And you need to be able to do them both for the exams, but this possibly needs a bit more practice. So remember, the first thing I told you to do to be able to plot an inequality is to turn it into an equality. So change that less than or equal to sign to an equal sign, 2000. Then we just plot it in exactly the same way we've done before. So to plot each intercept, to find each intercept, I'm going to let the other variable equal to 0. So in this case, I'm going to let m equal to 0 to find what h equals. So I'm going to substitute m equal to 0 into my equation and get an answer. So 80 times 0 plus 120h equals 2000. Now anything times 0 is 0, so 120h equals 2000. H is 2000 divided by 120, because we need to get rid of that number that's attached to the h. H is 16 2/3. Now you could of course use a decimal. It just needs to be written in a way that's easy for you to plot, that tells you what you need to plot. 2/3 I think, or a decimal is pretty good for plotting. So that's our first coordinate. Now our second coordinate we find in the same way, except this time we're going to let h equal to 0. So that's going to become 80m plus 120 times 0 equals 2000. 80m equals 2000. 2000 over 80 m equals 25. So you can see the process is identical. It's just algebraic rearrangement, and that's going to give us a coordinate of 25 and 0. So that's going to be our first 2 points that we're going to plot. Now remember, we needed to then go back to the original inequation to determine if we needed a solid line or if we needed a dotted line. And that was all based on the type of symbol we've got in our inequation. So because it's a greater than or equal to symbol, it indicates we need a solid line between these points. So we can now go and plot that. Okay, welcome back. So what I've done is I've created my set of axes that I need. So notice that M is on the x-axis and H is on the y-axis, and I've just plotted those 2 points that we have decided that we needed, and I've drawn the line between them. Now our next step is deciding which side of the line to shade. Now our equation, if we go back up to it, is not in a y equals mx plus c form. So the easiest way to determine which side to shade is to test a point. So that's what I'm going to do now. Test a point. And remember, you can do this no matter what form of the equation. But you must do it when it's in this form. So I'm going to test 0, 0. I'm going to put it into my equation, which was 80m plus 120h is less than or equal to 2000. So let's put 0 and 0 in for m and h and see what happens. So 80 times 0 for m plus 120 times 0 for h is less than or equal to 2000. So 80 times 0 is 0. 120 times 0 is 0, so it comes out as 0 is less than or equal to 2000. Is that true? It certainly is true. 0 is definitely less than 2000. So what that means is this point is, therefore 0, 0 is in our shaded region. It's in the region that we want to shade, therefore we're going to shade under the line. Therefore, shade under the line. So what we're interested in is under the line. Now we haven't got any negatives here because remember I said in some situations negatives don't make sense. This would be one of those. Negatives do not make sense because we cannot have negative microphones or headphones. So the region that we want for this first one is all of this under the line. So you take the time to shade it nicely. Okay, so that's our very first inequation that we're going to plot. Now, we also have to plot our other two. Oh, and I should definitely label this. So this is 80m plus 120h less than or equal to 2000. Now, I also need to plot my other two inequations. So let's go back up to them. M is greater than or equal to 12. H is greater than or equal to 0. So remember when we talked about these inequations with single variables, is what it's saying is what we've got is a line that goes through M at 12. And because there's no H in that equation, then it's never going to touch the h-axis. It's going to be parallel to the h-axis. So what that means is, so 12 on the m-axis would be approximately there. And it's a solid line because we've got that greater than or equal to line as well. So it's a solid line and it's going to go straight up and it's going to be parallel to the h-axis. The next one, h is greater than or equal to 0, is similar. So we find h, which is 0, and in this case, and I'm going to change the color here, in this case, the line that we want is actually going to go along our m-axis. So it doesn't actually cut the m-axis, it just follows the m-axis. So this is going to be h is greater than or equal to 0. And again, we don't want lines that cross our axes in any way. So let's do the shading that relates to them. So m is greater than or equal to 12, then obviously it has to be above this line. It has to be above where m is 12. So the shading for this one is going to be all of this. So you can see we're already starting to get an overlap where we've got two inequations that are true. So the region that we're after is where all of our things are true. And we also need to shade, and let's try and find another color. Maybe we'll find this pinky one,